Dear friends, welcome to my video on what is the need and origin of quantum mechanics. Kindly click on the CC button for subtitles. An unpredictable origin. Our story kicks off at the dawn of the 20th century, a period brimming with discoveries and radical theories. Scientists like Max Planck and Albert Einstein were throwing curveballs at the established norms of physics. While unraveling the secrets of the black body radiation and the photoelectric effect, these guys bumped into the necessity of looking at energy in discrete packets, or quanta. And just like that, the first seeds of quantum mechanics were planted. You see, before all this quantum buzz, we had classical mechanics, the brainchild of Sir Isaac Newton, who had it all figured out for the macro world. Things were predictable and followed clear-cut laws. But when it came to atoms and particles way smaller than the eye could see, Newton's laws were about as useful as a chocolate teapot. Enter quantum mechanics, the rulebook for the teeny-tiny particles making up our universe. Needs must. The push for quantum mechanics as the 20th century progressed, the need for a more refined explanation for the nanocosmos became glaringly apparent. Theories that were once set in stone began showing cracks as experimental results defied explanation through classical mechanics. A particularly cool experiment, the double-slit experiment, turned everything on its head. Picture this: particles behaving like waves and creating interference patterns, something only waves should do. It's like seeing your cat both inside and outside the box. It defied all logic but was happening right before scientists' eyes. Erwin Schrödinger then stepped in with his wave equation, a mathematical beauty that could predict the behavior of these particles, waves, with astonishing accuracy. It's almost like he handed us a magical pair of glasses that suddenly allowed us to see and understand this bizarre quantum realm. Strange bedfellows, quantum superposition and entanglement. As researchers delved deeper, they uncovered phenomena that seemed straight out of a sci-fi movie. Quantum superposition, for instance, allows particles to be in multiple states at once, defying the boundaries of classical logic. Then there's quantum entanglement, a phenomenon that would have particles entwined in such a way that the state of one instantly influences the state of another, no matter the distance separating them. It's the universe's version of instant messaging. These oddities nurtured the need for a theory that could encompass the fantastical behaviors observed at the subatomic level. The old rules just couldn't cut it anymore. Quantum mechanics embraced the weirdness, offering a mathematical framework that could describe the antics of particles that refused to play by the classical rules. A dive into the quantum realm with the likes of Heisenberg, Dirac, and Bohr contributing massively to the field, quantum mechanics began taking a more solid shape, offering answers that classical mechanics couldn't provide. Werner Heisenberg's uncertainty principle, for instance, tells us that you can't know both the position and momentum of a particle at the same time. It's like trying to catch a super slippery fish with your bare hands. The more you know about one aspect, the less you know about the other. This all paints a picture of a subatomic world that's rich in possibilities and fueled by probabilities, rather than certainties. It opened up a vista of potential explanations and technologies, from quantum computers that could potentially outdo the mightiest supercomputers of today to encryption techniques that would be practically unbreakable. Hello quantum technologies. Fast forward to our current era, where the need for quantum mechanics has transcended from purely theoretical constructs to driving futuristic technologies. Quantum mechanics is not just about quirky particles anymore. It's the blueprint for the next generation of technology. Imagine computers solving complex problems in the blink of an eye, drugs being developed at a pace we could never have fathomed, and secure communication channels impervious to hacking. That's the promise of quantum technologies, and it all stems from understanding and harnessing the quirks of the quantum world. Understanding the nature of reality. Beyond the tech and the gadgets, there's something profoundly philosophical about quantum mechanics. It urges us to question the very nature of reality. Are there multiple realities branching out every moment, as suggested by the many worlds interpretation? Or does the act of observation shape the outcome, a view championed by the Copenhagen interpretation? As we ponder these questions, we find that quantum mechanics is not just a set of equations, but a lens through which we can explore the deepest questions about the universe and our existence. It takes us on a path where we may one day unravel the grand design, the theory of everything that ties the macro world of galaxies and the micro world of quanta in a neat bow of understanding. Conclusion: the ever-evolving quantum landscape from its humble beginnings as a theory to explain the odd behavior of light and matter at the subatomic level, quantum mechanics has grown to become the foundation for understanding the universe at its most fundamental level. Its discovery was born out of necessity, as classical mechanics faltered in explaining the nuances of the atomic and subatomic world. The quantum realm, with its superpositions, entanglements, and a dizzying array of other phenomena, has opened up new avenues of understanding and innovation. It has given us a glimpse into the strange, often counterintuitive, yet fascinatingly rich and diverse world that exists at the scales much smaller than the eye can see. As we stand on the threshold of a new era of quantum technologies, the need for quantum mechanics is more prominent than ever before. It's a field that encourages us to push the boundaries of what's possible, to dream bigger, and to dive deeper into the mysteries of the cosmos. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.